All right, today we're going to dive into a pretty foundational project in artificial intelligence, one that's all about giving computers a skill that is just so fundamentally human. This is the story of the AVI Corpus. You know that feeling, right? When you're watching a foreign film and the audio is just a fraction of a second off from the actor's mouth moving. It feels weird, kind of unsettling even, and there's a really good reason for that. Well, it's because our brains are these incredible prediction machines, and they are constantly automatically syncing what we see with what we hear. So today, we're going to explore the massive effort to teach computers that exact same skill by basically creating a whole new, super detailed language library from scratch. So to really get why this was so necessary, we first have to take a look at the communication gap that used to exist between us and our machines. Here's the thing about AI. For it to learn any complex task, whether it's recognizing a cat in a photo or understanding what you're saying, it needs data, a ton of data. We call this a corpus. And for a machine to learn how to connect the sight of speech with the sound of speech, well, you need a special audiovisual corpus. So the first big Persian audiovisual corpus was called AVA. It was brilliant for what it was designed for, which was speech therapy. But for broader AI stuff, it had one big limitation. See, it was built using only 2 speakers. And for an AI to really learn the huge variety in how we all talk, it needs a much bigger, more diverse group of people. And that's exactly where AVA II comes into the picture. Okay, so how do you even start to build the perfect dataset to teach a machine to speak? Well, you don't just grab a camera and start recording. No. You have to create this incredibly meticulous scientific blueprint first. It all starts with the absolute fundamentals, right? The building blocks. The researchers broke the Persian language down to its core components, 23 consonants and 6 vowels. Every single word, every sentence, is just some combination of these 29 basic sounds, or what linguists call phonemes. But here's where it gets really tricky. We don't say these sounds in a vacuum. Think about it. The way you shape your mouth for the t sound in the word to is actually different from the t in T, and that's all because of the vowel that comes right after it. This is a super important idea in linguistics called coarticulation, and it's absolutely essential for making speech sound natural. Now, this is where things get really clever. To capture that coarticulation problem without, recording every single word in the dictionary, the researchers did something brilliant. They recorded every single consonant combined with every single vowel in 3 core patterns: consonant-vowel, vowel-consonant, and vowel-consonant-vowel. This approach just perfectly captures that incredible level of detail you need for a truly useful dataset. Of course, we don't just speak in single syllables. To get the flow of natural, continuous speech, the researchers also had the speakers read 20 common, phonetically balanced sentences, and they had them say a series of numbers as well. And here is just a fantastic little detail from their process. They originally wanted the speakers to count from 0 to 20, but they noticed that people tend to kind of trail off. They pronounce the very last number a little incompletely. So to make sure they got a really clean recording of the number 20, they had everyone count all the way to 21. Just a simple, clever fix to a very human quirk. Okay, so the blueprint is locked in. It was time to head into the studio and actually create this massive library of language. They didn't just plop one camera down and hit record. Oh no, this was a super precise 3-camera setup to capture every possible angle. You've got the frontal view to see the face like we normally would, then a profile view, which is great for things like 3D modeling, and then a dedicated close-up camera just for the lip area. And get this, for the AVA II corpus, they even added a special camera placed just slightly below the main frontal one. Why? Because that angle gives you a much better view of the tongue and the teeth, which are absolutely crucial visual cues for making certain sounds. It just shows you the insane level of precision they were going for. And the speakers themselves, they were chosen so carefully. 14 people, a perfect 7-7 split of men and women, all native speakers with that standard Tirani accent and no speech disorders. They even had them wear white clothes to stop any colored light from reflecting onto their faces and messing with the visual data. Now you might be thinking, wouldn't the easiest way to get someone to say all this stuff be to just have them listen on headphones and repeat what they hear? Well, the researchers made a very specific choice not to do that. So why not? Turns out there were 2 really smart reasons for this. First, when we repeat something we hear, we can't help it. We unconsciously start to mimic the accent of the person we're listening to.
They wanted the speakers totally natural voices. And second, having them read the prompts off a PowerPoint slide actually made them use a more formal, consistent pronunciation. It's a subtle thing, but it's a brilliant piece of experimental design.
So after weeks and weeks of recording, the team was sitting on a mountain of data, about 90 minutes of high-def, multi-angle footage for every single speaker. The next huge challenge was how to organize all of it into a library that other scientists could actually, use. So they built this super clean digital filing cabinet. Everything was organized first by a unique ID for each speaker. Then, inside each speaker's folder, the data was split up by the camera view, so frontal, profile, and lip. And then within those folders, every single clip was categorized by what was being said, a sentence, a number, or a specific sound combination. It makes finding exactly what you're looking for incredibly fast and easy. So, after all of that painstaking work, what's the big payoff? I mean, why does building this incredibly detailed audiovisual library actually matter in the real world? This data is basically the launchpad for some incredible technologies. You have audio-visual speech recognition, or AVSR, which lets your voice assistant understand you way better in a noisy bar just by reading your lips. It's the key to getting perfect automatic lip syncing for dubbing movies or for video game characters. And it makes things like visual speech synthesis possible, creating totally realistic, talking digital humans. At the end of the day, the AVA II corpus is like this amazing gift to the entire global research community. It provides the raw materials, that fundamental knowledge that lets scientists anywhere in the world build more natural, more intuitive, and just more seamless interactions between us and the machines we use every single day. And the team behind this, they're already looking at the next big thing, emotion. I mean, we've taught machines to understand what we say. What happens when our technology can also understand how we feel? That's a question to think about.